show you is over on the right, you kind of have a trace for each command as to, what its parent command is. So you can kind of step through this and, you can then see for each command, what directory you step through, how long it took, and, in various other ways verify that you have a correct understanding of what your build is doing. All right, cool. Well, let's get back now for a moment to the defects and the Build Explorer. There are 5 what we call checkers, and checkers look for different types of rules that are violated or things that are possibly not the way you want them to be. I'll start with one that I already mentioned that's kind of simple and straightforward, and it's called leaked files. Leaked files compares what your build produces to what's still left behind after you run your clean command. So we examine the tree after you run make clean, and we compare that to the list of files that we know the build itself generated. And those files, which would be listed here, and you can see that this particular build only left 1 file behind. We can click on it. First of all, we see immediately the command that ran it, and up here we see exact context. So it's a sed command, which was called from this bin sh-c sed pipe to sed something else, and that was called from make-c libpq all, which was run in the source interfaces directory. What we can see is that the file that was left behind is called interface libpq, libpq.rc. 2 possibilities here. One is this file only needs to be generated if it does not already exist, in which case this defect is not, it's intentional, right? You don't care about regenerating this file every time. If it doesn't depend on anything that could change, that means you're going to get the same one every time. And maybe that's kind of, intentional and you don't care about fixing it. It doesn't really seem to be the case here. It seems that since the input involves date, that maybe there's supposed to be some sort of a timestamp. And in that case, you might want to go and figure out, does make clean try to clean it up and just miss it? Is make clean not properly run within this directory? Just like with with a lot of other static analysis, we can tell you what we've observed. We can't tell you, A, if it was done intentionally, or B, if it wasn't, what the best way to fix it is. That's up to you because, well, you know what might have been intended, and we only know what actually happened. So now, let's look at another one called duplicate processes. So duplicate processes is a situation where we say, hey, you are running something, exact same process more than once, and it seems like what it's doing is the same thing because the command is the same, and the directory in which it's happening is also the same. So and I forgot to mention, you can actually, occasionally you might see where there's lots and lots of duplicate processes. I think maybe Python had where you sorting by number of instances can help you concentrate on the ones that are maybe more impactful of performance. On the other hand, some may be impacting correctness, where you might determine that, hey, I'm not sure why this is being invoked twice. Now, this one I happen to look at, and when you invoke it, if it had already run it, it actually doesn't do anything, and it seems to exit very quickly. So it's probably not impacting things, and then, I didn't dig into it too closely. There may be a good reason why they need to run it multiple times, because maybe depending on the state of things, of other things that ran in between, maybe its action would be different, right? Because, there's a number of actions that happen in between, any of which could change the state of that directory. So even though we're in the same directory, the action could be different. So these could be intentional. And again, you may decide whether you want to restructure the build, take out duplicate commands, or, just mark them as being intentional and ignore them. File access violation is probably one that, other than the policy checkers, you want to configure. Because what it's says is, I'd like to see a set of rules, and we start you out with a certain default rules, and you would then kind of tune them based on your requirements, but this assumes that there are certain files and directories that you don't want your build accessing. So for example, if your build is running in a particular ClearCase view or something, it should only be accessing things in that view, and then maybe the place where your toolchain is installed. Or maybe your toolchain is actually in that same view, in which case maybe it shouldn't be accessing anything outside of the view. In which case your rules would be to explicitly allow access to particular directories and files, and then disallow everything else. So the rules are specified, maybe, those of you who've done some system administration, this might look a little bit like a cron job kind of a specification. But this says, right here, the rule that's being violated is the catch-all rule that we put at the end of every rules file. And that says disallow access to everything. So any rules above that in the config file that allow things supersede. So if it says allow access to /view/ something, or allow view to current directory and anything below it, and allow allow read and write to /user/ local /bin /star or something like that. And then at the end we say disallow everything else. And this is a way to see what is your build accessing and how, and make sure that, hey, is it really supposed to be? So right here I just, let me actually sort this by reads and writes. First of all, I want to see where am I writing stuff. Oh, I go, silly me. I forgot to add to this checker that access to /temp is allowed for both reading and writing. So at this point I would go back, I would modify my rules file, and I would rerun the analysis, which only takes a few seconds. I would reload the new defects, and then all of these would be eliminated. Then I'm going to be like, why am I looking at stuff in this directory? So, I would determine, is this something that should be exempted and allowed, or are things being picked up in the wrong place? And this is where, after tuning, this can help you catch somebody inadvertently setting up some change in the build that picks up include files from the wrong directories, or picks up a wrong version of the compiler, right, not from the appropriate approved installed place, but from some other generic place where maybe the wrong version lives. So these are all reads. Notice, we're reading attributes here is what we're showing. You can see user lib exec gcc, Red Hat 4.0 cc1. Is this the right version? And, if it is, let's put it in the rules file as being allowed, and then it would be eliminated. Hopefully this makes sense. So, sometimes, you run this and, you see something that might be really surprising, right? So other times you run it. Here's one that I ran with a very well tightly configured file access violation file, and I only ended up with one violation. So it looks like this runs /user/convex gets this info, and it looks like the configure command is what runs this, among other things it does. So now I go, okay, I guess that would be okay, and I'm going to add this to the allowed things. Or I might look at this, for example, let's say this just popped up after my build's been running for a while, and I might now say, hey, you know what, we don't want to be relying on this thing being there, right? Because if it's not there, then my build might fail. So I might, assign this back to the last person to check in a change to the make file, or however our process is for changing builds, and say, hey, user convex is not only approved, guaranteed to be their directory list. Could you please change the build in a way that does not rely on that? And this will pick up, whether you're referring to disallowed files via symbolic links or referring to them directly or anything else.